All right, guys, lesson 8. This is one of my favorite types of factoring because it's kind of easy, and I hope you find it the same way. We're doing differences of squares. We're going to throw in some problems in here that are more challenging, as well as the super simple. This also comes in handy all over the place. So we're going to start with just kind of the notation of how to do it. So factoring a difference of two squares. We have a perfect square here and a perfect square here, then and a subtraction in between them. So a difference of two squares, hence the name, right? Then it factors. We do two sets of parentheses, open, close, open, close. We do, now this is hard to tell from just looking at this. The way I teach it and the way we're going to think about it in the examples is you do this for the first slot, you do the square root of the first term. And that's going to make more sense when we see things that are not just a and b. So this would be the square root of a squared, right? The square and square root cancel, leaving us with just a, right? And then the square root of the second term for the second part. So the square root of b squared, which would be just b. And then plus and minus. You'll see some people do minus and plus, same thing. That's either way, right? Okay, let's do some examples, put some meat on it, make it make sense. All right, so we're just going to jump straight in with factoring things. So the first problem is right here. We're going to factor b minus 4, b to the fourth minus 16. So we need to identify, is this a difference of perfect squares? Well, it is. This is a perfect square because b squared squared equals b to the fourth. Keep this in mind for in a second. And so that works. We're looking for even powers if it's variable. So if it has even powers, then you're good with variables. And perfect squares with numbers, we're looking for perfect squares. Now, I'll remind you what those are. We've talked about that a lot recently. So like 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 20. What am I writing? Is 25, and you can keep on going. 36, 49, et cetera, et cetera, et cetera, right? There's infinitely many of them, but those are perfect squares. So, right, if we have a difference of two perfect squares, then that's what we're cooking with here. So we've got a difference of two perfect squares. So we're going to factor it just like I just said we're going to do. We're going to do open and close and open and close. Okay, so we need, in the first slot, we need the square root of the first one. So we need the square root of b to the fourth. So I'm going to kind of talk this out, and then I'm going to tell you an easy way to think about it with the exponents. It kind of goes into the way I'm going to explain to do it kind of is actually kind of using rational exponents, which is something we haven't learned yet, but it's kind of an easier way to think about it. But I'll show you what we're doing, and it's going to be just like what we just did. So if we want to take the square root of b to the fourth, we want something where the square and square root are going to cancel. So we could turn this into b squared squared, square root of that. So the square and the square root cancel, leaving us with just b squared. Now, an easy way to think about what it's going to be without having to do all of that work is you're just going to take whatever the number is in the exponent and you're going to divide it by 2, right? So if it's squared, then divided by 2 is... got ahead of myself. Divided by 2 is 1. If it's the fourth, then it's going to be 2. If it's the sixth, it's going to be cubed, etc. You're just going to divide it by 2, and that's all you're really going to do. Okay, so then the square root of 16 is 4. So the square root of the first, the square root of the second, plus minus. Now you might be like, well, let's circle that and move on, but wait a minute, there's more, because in this particular problem, we have another difference of squares right there. Right? This one's not. That one's not a difference of squares. We can't factor him anymore. He's as factors as he's going to be. But this one right here, we got another difference of squares, so we need to factor that as well. So again, 2 sets of parentheses, square root of the first. So 2 divided by 2 is 1. So b to the first. Square root of 4 is 2. Plus, minus, what do we do with this one? Just bring it down. So b squared plus 4 times b plus 2 times b minus 2. Easy peasy, right? Let's take a look at this one. Now, this one's a little bit crazy, right? We got the variable over here. We got the numbers over there. What do we do with that? Well, we have to leave it in this order because we need the difference to be in the middle, right? So we're gonna, other than that, we're gonna do it just like the same way. So two sets of parentheses. The square root of 625. Now you might be like, what's the square root of 625? And if you're like that, then you can just pull up your calculator and be like, square root of 625, and you end up with 25. You may have known that already. Some of you undoubtedly did, but in case, I like to normalize the use of calculator for some spots. It's a good plan. Square root of this one, divide that by 2, so x squared. Let's make that 2 into a 2. Plus, minus. Now we have the same thing going on here. We have another difference of squares on this one. So we're going to bring down the 25 plus x squared. There won't always be there may, on some of the problems, you may be done right here. We circle it and move on. But you always want to check and make sure there's not something else that we need to factor out. Okay, so the same idea here. Two sets of parentheses. Open, close, square root of 25 is 5. Square root of x squared is x. Plus, minus. Easy peasy. Now this one right now is not a difference of two squares. 27 isn't a perfect square, 3 isn't a perfect square, g cubed and g to the first are not a perfect square. So you might be like, okay, it's prime. But wait, there's more. You can factor this. You may, the astute among you may have already seen what to do. And what you're going to do is you're going to look for that GCF. Remember, we're always going to want to look for a GCF. So is there any common factors here? Well, 3 goes into both of them, so we're going to pull a 3 out. And G goes into both of them, so we're going to pull a G out. And then when we do that, what is left? Well, in the first one, 27 divided by 3 is 9. G cubed divided by G is G squared. And this one, there's only a 1 left. That's, again, I've said this on this particular issue before, but that's an easy place to make a mistake. 3G divided by 3G is 1, not 0, right? Now, circle it. We did a thing. No, there's more to do, right? We've got a difference of squares here, right? So we're going to bring the 3G down and split this, open, close, square root of the first. So now the square root of all this mess, right? Square root of 9 is 3. Square root of G squared is G. Square root of 1 is 1, right? Because 1 times 1 is 1. Easy peasy. Plus, minus. No big deal. Let's do another one. Actually, another 2, I think. Yep. I was right. Now we got all kinds of mess happening, right? As over here, we've got 4 terms. I know I'm in the wrong layer. Calm down. Okay. Over here, we've got 4 terms, right? No GCF in all of them. So we're going to factor this by grouping, but then we might also have difference of squares. We'll see what happens. Indeed. All right. So then this one, well, we'll get to that one in a minute. So for this one, let's go back and take a look and see if we can figure out what to do with it. Okay. So like I've said before, if we've got 4 terms and the instructions say factor, then we look for and got to probably factor by grouping. And that's exactly what we're going to do. We're going to split it in half. Now you may already notice that the signs are backwards. So on the second one, we're going to pull out a negative in order to make the signs match. So we're going to go ahead and do that early, right? So what's in common on the first 2? Well, x squared is in common. We take an x squared out. We're left with an x on the first one and a 3 on the second one. We are going to pull out that minus on the second one, and so that we get the signs to match. Now, other than that, there's nothing in common, right? So we just flip the signs, x plus 3, and then, wow, that's going to match, right? So the x plus 3s are in common. So we're going to pull out the x plus 3, leaving us with x squared minus 1, right? There's that 1 right there. Now you see where this fits in this lesson, right? Because now we've got a difference of squares to deal with. You thought this was we've gone back a few lessons. Yes and no, right? So we're going to factor this. So bring down our x plus 3. And then open, close, Square root of the first one, square root of the second one, plus and minus. No big deal. All right, let's take a look at this one. So again, on this one, we're looking for that GCF. So we have 5 that goes into both of them. So we're going to pull out a 5. There's also an x in both of them. So we're going to pull out an x. When we do that, on the first one, we're left with x to the 4th. On the second one, we're left with minus 9, because 45 divided by 5 is 9. X divided by x is 1, right? Now we've got a difference of squares. So we're going to bring down the 5x, open, close, open, close. Square root of the first one, so x squared, and x squared, and the square root of the second one, so 3 and 3. And plus and minus. You might be like, well, we could factor this more, but 3 isn't a perfect square. Now, if we want to get really technical, we could factor this into x plus the square root of 3 times x minus the square root of 3. But at this point in our math career, this is fine. Where we're at on this problem is totally fine. So we're going to circle it and move on with our life. We got one more page. So now we're going to solve by factoring. We've also thrown in a new thing, kind of, right? So we're solving a quadratic, right? So we're going to get 2 answers, or at least 1 answer, maybe 2. Well, we'll leave that for Algebra 2, that whole discussion, at least for now anyway. So we need to factor this. So we're going to factor it. Bring down 0 equals. So open, close, open, close. Square root of the first one is easy peasy, right? X times x is x squared. Square root of x squared is x. Right, now the second one, we're doing the square root of 9 over 16, which is actually maybe easier than some of you are thinking, because when we square root a fraction, we have the square root of the top over the square root of the bottom. So square root of 9 is 3, square root of 16 is 4, so it's just 3/4. Fractions are not necessarily scary. It's going to be okay. 3/4, 3/4, plus and minus. Now to finish solving, we're going to split it into 2, right? So it's going to turn into x plus 3/4. You may already see the finish line. And x minus 3/4. So when we subtract 3/4 from this side and add 3/4 to that side, we end up with x equals, I'm going to write it in a condensed form. We could write 3/4, comma, negative 3/4. We could also practice saying that plus or minus 3/4. That's nice. Easy peasy, lemon squeezy. That's it for factoring difference of squares. Hopefully it's making sense. If you're one of my students, I'll see you in class. Otherwise, have a great day. Well, everybody have a great day. All my students included. Bye-bye.